Hello, I'm Sasanka. Today I'm going to talk about my work on semantic understanding based visual inertial navigation for indoor dynamic environment. Imagine a drone working in a warehouse. Drones are efficient, versatile in reaching all the space, and safe to operate, cost effective because of the minimum infrastructure requirements. However, a warehouse is a DPS denied indoor environment. Drones require visual inertial navigation systems to operate. And also, the warehouse is a dynamic environment. Dynamic environments can cause issues in visual inertial navigation systems. Imagine this is what the drone sees. In traditional VINS, features are detected, tracked, and sent through the VIO backend to generate odometry. However, when there is dynamic objects, the features generated by them can be considered as dynamic outliers because when tracked, these dynamic outliers cause issues in visual odometry. We introduce a dynamic outlier remover into the pipeline which avoid these dynamic outliers from reaching the tracking stage and in turn generate good odometry. The proposed method achieves improved accuracy with minimum runtime cost compared to the base VINs in dynamic environments. Notably, it also achieved real-time performance on edge hardware. For a more detailed analysis, please refer the paper. This is OpenVINS, an open source, cutting-edge visual inertial navigation system. We seamlessly introduce a dynamic outlier detector and a dynamic outlier remover into the pipeline. First, we classify the potential dynamic objects in the image frame. To do this, we create a synthetic dataset in ISAC-SIM and train YOLACT Edge on that dataset. In this step, we detect all the potential dynamic objects in the image frame. Next, we classify the dynamic outlier among the detected potential dynamic objects. We start with a true dynamic object. In this case, it is the human in the image who is also masked in red. Next, we try to detect the overlap of this mask with the other detected masks. When we detect it, we have marked it in yellow here. And then we filter out objects like the box in the background using the depth information available. And then we repeat these two steps recursively to detect all the other dynamic objects available in the frame. Now we have detected all the dynamic objects. Now the mask is ready to be post-processed. We do it in two steps. First, we detect the incomplete mask and extend this mask using the depth information. And then we try to address the issue of inconsistent detection of the segmentation network by tracking the detected mask temporally. This is the result after tracking. Now the detection is ready to be sent to the dynamic outlier removal. In this step, we simply remove the features that are inside the dynamic outlier mask before the tracking stage of the VINS. Okay. Now, to prove the concept, we conduct simulation experiments in gazebo and real-world experiments in edge hardware. In both cases, we are able to achieve real-time performance. Finally, we showcase the performance of our method in a warehouse environment. You can see down here, the method is detecting and removing the dynamic outlier features in real time. And as a result, you can see on the right side, the drift induced by these outlier features is not present in our method, which is shown in red. You can see the final results now. Thank you.